Hi, welcome to the Onritsu Network Master Pro Flex CPRI demonstration. On booting the equipment, we're up and ready to go. We'll move down to the CPRI application here. We'll talk about CPRI today, so while I load the CPRI application, which takes a couple of seconds, I will now flip over to the CPRI PowerPoint to explain a little bit more about the technology. So as we can see here, we're going to talk quickly about the evolution of a tower, and when we look at the tower situation, the old networks used to obviously have a node B, or a base station controller, down the bottom. Up the antenna with a coaxial cable connected here. Used to be quite heavy and also required all the dedicated equipment at the base of the antenna. Distances were quite restrictive. Moving on to the newer networks, or the RF networks, antennas, we have a remote radio head at the top, which basically meant they split their node B into two with a BBU at the base, an optical fiber, and a power cable here. This allowed them to minimize a little bit of equipment, shrink the hut slightly, and save on power for things like the AC and the UPS. Moving into the CRAN, a centralized RAN situation, what that's really allowed the operators to do is move the BBU back to a central location, even more minimizing the huts at the base of the antenna, once again saving mainly on areas such as power, because they basically just have a simple switching mechanism inside these huts, with all the intelligence coming back to the BBU at the central side. Multiples of these remote radio heads can be connected back to the one BBU, optimizing the cost performance of the network. So let's move on to the testing scenario. We have the same sort of diagram here. Let's break it down into the phases of installation. These are quite common in the industry. We often see that on the installation of the antenna, we need a climbing crew. Often this is a totally different crew of technicians to complete this job, mainly because they have to work at height, and that takes specialized skill sets. So with installing the remote radio head at the top of the antenna here, obviously the optical cable and the power feed, it's quite common that you'll test that with an OTDR, loss test set, and the type of test you'll want to do is complete round-trip time or a round-trip delay type measurement. And also just as important is to be able to somewhat emulate the hut. So if you look at the CPRI standard, the CPRI Release 6 or version 6 of this standard, it talks about a passive link state, which is where when the remote radio head is connected to equipment, it will get to a communication stage and go into the passive link state. So the link is connected. You can check the protocols are working correctly on the link. Basically 100% confirming that your remote radio head is up and working correctly. The second phase of the installation will commonly be when the hut is placed here. Now this could be either way. It could be with a node B at the bottom, or it could be just with the remote BBU placed further back. In this situation, you could of course check optical levels, your transmit and receive connectivity, your remote radio head is correctly connected with the correct rates, and if you want to do something like the CPRI BERT or a round-trip time, then that would require a loopback at the top of the antenna, replacing the remote radio head or your remote radio head having the option to loopback. You would of course have to talk to your vendors of the remote radio head with regards to that. The third phase of installation is commonly just testing of the ring, the DWDM or CWDM, coarse or dense wave multiplexing of the ring. In this situation, it is not normal in CPRI today that it is a real ring configuration. It is actually normally more of a Y connection from the BBU out to each of these individually, and each of these elements are switching the opposite direction. But for simplicity, we are showing it here as a ring. So when we look and have everything come back as a total, commonly the things that need to be tested here is the course from your BBU to each of these network elements, that it is error-free. You could do that by looking at the layer 2 alarms of the CPRI protocol. You could also look at it in a pass-through mode on the test equipment to check that everything is working. And of course, if you needed to, with looking at round-trip time, which is extremely important in CPRI, you could turn around and put loopbacks at the top of the antennas, as drawn here, to check your round-trip time, or you could check your round-trip time from the instrument to the base. Obviously, in this case, instrument to instrument, you no longer require a situation of a climbing crew. So depending on the operator's structure of engineers, this can make quite a difference to how the test is completed. Lastly, if it was, which is not common today, installed with an OTN, optical transport network, in this ring situation, it could be tested over OTN, CPRI over OTN. So moving back to the equipment, we can see here it's booted. We are connected in our normal mode. We are connected here at a 10 gig CPRI rate. The version 6 highest rate of the CPRI standard. If we wanted to, we could move across to our CPRI layer. We could, of course, test that in an unframed situation and just do a basic BERT test over the CPRI layer. In this case, we'll do a full CPRI link, where we have the option of selecting things such as the HDLC, or the Communications Protocol rate. In this case, 2400K HDLC, the different CPRI version types, and so forth. We could move across now to our test setup by clicking the word at the bottom test, or just by clicking the right thumb button. In clicking the right thumb button, we can look at our interval lengths for our measurements and other types of areas such as start-stop times. The delay in this case, we could select to check the delay measurement here. So across the CPRI protocol, I am checking the delay is greater than 10 microseconds. And from here, it would just be a simple matter of starting the test. So once our test starts, we'll see here that we have the CPRI error and alarm level in the summary screen with no problems, our round-trip delay with no problems. So by clicking on this button here, our CPRI error and alarms, we jump up to our Statistics tab, and we can now see the Statistics view here. We can see here that we have no problems across the layers of the CPRI protocol for our errors and alarms. If we wanted to, we could quickly jump to our round-trip delay by selecting here, and now we can see here that we have no major delays in our round-trip time, maximum, minimum, and average of our link under test. So what we could do here, moving forward, I guess, to a more advanced style of testing, is we could stop this test and then move into, if I go back up, back at the main interface, let's start a second port, change my optical configuration on the top of the unit, and in selecting the second port, we will then now come into the interface of port 2. So we can see here at the top of the screen, we are now on port 2. I'll change this from through mode to normal, much like the last configuration, the fourth configuration we discussed earlier. And in here on my CPRI layer, notice I've got 960K HDLC selected, and let's just see how that can affect the situation. So if I start my second port, switch back to my first port, I'll start my first port as well. Notice that it was on the 2400K HDLC. So by looking here, we could get a quick, simple overview to see that our receive is at 960 and our transmit is at 2400. So not a normal type of configuration here, which would normally be looked at. It's possible for the protocol to do that, but it's just not a normal situation. So nice easy introduction here to CPRI and testing on CPRI and how the whole interface works. If you have any questions, please don't hesitate to contact Anritsu.